Until now, we have seen regression analysis. Before regression, we have discussed basic statistics and Python, because Python is the tool that we are going to work on. All these machine learning, we are practicing on Python. But the tool, does it really matter? Tool doesn't matter, isn't it? You can work on any tool. Machine learning is tool agnostic. Agnostic means the tool, whichever tool you work, machine learning doesn't change. The formulas, they don't change. Then we discussed some of the basic statistics. Those are fundamentals. Then we went on to discuss the data exploration, data validation, data cleaning, because we realized that raw data directly cannot be taken for building a machine learning model. We have to apply various techniques for data cleaning. Remember, we have discussed some of the techniques in data cleaning. There can be some other heuristic techniques as well that other companies must be using. Okay, so you can follow even some other techniques when you join a company. Maybe some other company must be following some other heuristic data cleaning techniques. Few of them is what we have discussed here. Okay, later on we went to discuss regression. So for what kind of output regression is perfect? Are you going to build a regression model for predicting every type of target, or it is meant for predicting a certain type of target? Regression is meant for predicting only of the target type, and the target variable y is continuous. In that case only, you will use regression. One of the frequent interview question is, what's the difference between regression and logistic regression? So what will be your answer to that? Your answer would be regression is used for predicting the continuous variable as the output target, whereas logistic regression is used when the target variable is categorical or discrete type, where you are predicting. You can give some examples. When you're predicting sales, you can use regression. When you're predicting a customer will buy the product or whether the customer will not buy the product, in these cases, you can use logistic regression. Okay. Now, today we are going to discuss decision trees, and in which scenario we use decision trees. Decision trees are specialized in predicting or in doing the customer segmentation. What is it? Customer segmentation. Because whenever I'm introducing a new machine learning algorithm, there must be a reason why we are introducing that. Why can't we simply use regression everywhere? The answer was it fails when the target variable is categorical. Why can't we use logistic regression everywhere? If you want to do customer segmentation, logistic regression is not suitable. We are going to use decision trees for customer segmentation. Now I'm going to explain you what are decision trees, how can you use them for doing the customer segmentation, and then how do you apply decision trees on a data set, how do you build those segmentation strategies. So the problem statement on the face of it, it looks very simple. It looks very similar to the general problem statement that we hear. What is it? I have feature x1, I have feature x2, I have the target variable y. Feature x1 is gender. I know the marital status of the customer, and the target variable is whether the customer has ordered the product or not. I have gender, marital status, whether the customer has historically ordered the product or not. Some customers did not order, some customers have ordered the product. Some of them did not order, some of them have ordered the product. Now, what I want to do is I want to build a model. I want to build a model on this data, and it has to make predictions. When the new customer comes in, customer gender male, marital status is married, is this customer going to buy the product or not? That's what the model has to predict. The new customer has logged in. From his profile, we got to know customer is female and marital status is unmarried. Is this customer going to order the product or not? This is what this model has to predict. Now, this looks like a typical case of logistic regression or typical classification type of problem statement. Isn't that true? Doesn't it look like a classification type of problem statement where you have some features you're predicting whether a customer will take this or this, 0 or 1, order the product or not? Now, for the classification, you can use logistic regression, but decision trees will solve this problem in an entirely different manner. Decision tree follow a very different approach. They will give you these predicted values, but the approach followed by decision tree is very, very different. Let me give you the philosophy of the decision tree. First, we will try to understand the overall philosophy, just the analogy. Then we will get into the theoretical nuances. Then we will get into the actual application on a data set and the coding part. Okay. So now, what am I going to do? I'm going to tell you the philosophy of the decision tree, how decision tree will give you the predicted values of these customers. What decision tree tells you is you have a data set. Here, I'm showing you a smaller data set just for the demo sake, but the actual case study that we are going to do later on will have thousands and thousands of rows. So this is the data set. What decision tree tells you is do not look at the whole data as one group. No, do not look at the whole data as one group. Divide it into smaller groups or arrange this data in the form of a tree structure. Rearrange this data in the form of a tree structure. You yourself will be totally surprised. Once you rearrange this data in the form of a tree structure, the predicted values will be very easy to make. So listen to me. Right now, this data is simply one data set. Just rearrange this data in the form of a tree. Then your predictions, you can make it very easily. That's what decision tree tells you. Don't look at the whole data as one group. Now, how do I rearrange this data? Here is the process. Overall, there are 14 records, right? So there are total 14 records. Out of those 14 customers, 10 customers are not buying the product. 4 customers are buying the product. 71% are no, 29% are yes, buying the product. Now, do I have the gender information of the customers? Yes, I do have gender information. What I can do is I will divide this data based on gender. There are 8 male customers. There are 6 female customers. Within 8 male, there are some customers who are buying the product. Some customers are not buying. The same thing goes on in female subset as well. Some customers are buying the product. Some customers are not buying the product. Now, I further divide this segment into further groups based on marital status. These are the customers who are male married. These are the customers who are male unmarried. Some of them are buying. Some of them are not buying. Female married, female unmarried. Some of them are buying. Some of them are not buying. So overall, I have 14 records. I have divided them into 1, 2, 3, 4 subsets. Subset 1, subset 2, subset 3, subset 4. These 4 subsets are also known as 4 segments or subgroups. That's what decision tree tells you. Do not look at the whole data as one group. Divide them into subsets or subgroups. These are known as segments. Divide them into segments. Now tell me, this is new customer. I don't know what he's going to do. If I ask you the same question, customer, gender is male, marital status is married. Is this customer going to order the product or not? What do you think?
No, sir.
No, sir.
No.
This customer is not going to order the product. What about this customer? Customer 2, female, unmarried customer. Is this customer going to order the product or not?
Yes, sir.
Yes, sir. Yes, sir.
There's a high chance that this customer will order the product. Are you making some random guesses, or is there a logic behind why are you saying no here? Why are you saying yes here? When I say customer is male, married, what are you doing? You're looking at historically what happened. Historically, most of the male married customer did not buy the product. So what do you say? There's a high chance that this customer may not buy the product. Yes or no?
Yes, sir.
The same way, historically, most of the female unmarried customers have purchased the product. You're also going to say, yes, they are going to purchase the product. That's what I have observed in the data. Now, that is what decision tree tells you. Philosophically, what is the main philosophy of the decision tree? Do not look at the whole data as just one group. If you look at the whole data as one group, you will not be able to take the final decision. Divide the data into subgroups. In such a way, if you look at the whole data as one group, it will be very much impure. What do you mean by impurity? I'll come to the questions. Just give me a second. Okay. We will have a logical stopping point. At that time, I'll take all the questions. Just try to absorb as much as possible right now. Okay. So right now, what am I saying is overall data set has impurity. What do you mean by impurity? If you look at the whole data, there are some customers who are not buying. There are some customers who are buying the product. That means both class 0 is there, class 0 as well as class 1. Both the classes are there. Out of 14, some of them are buying, some of them are not buying. If the data is impure like this, what do you mean by impurity? Both the classes are there. You cannot make a decision. If I give you this data, overall data, both the classes are there. You cannot make any decision. Divide the data into segments or the subsets which are pure. What do you mean by purity? If you take 6 customers, all the 6 are not buying. This is a pure subset. Only one class is dominating. Is this a pure subset? Is this a pure subset?
Yes, sir.
3 customers are there. 3 of them are buying. So definitely this is a pure subset. What about this one? Is this a pure subset? Segment 3?
Yes, sir.
3 customers are there. 3 of them are not buying. This is pure. That means if a customer falls here or here or here, we can very confidently say what he is going to do. What about this one? Is this a pure subset?
No, sir.
2 customers are there. That means if a customer falls here, if I tell you a customer is male, unmarried customer, will you be able to make a decision that whether he's going to buy the product or not easily?
No,
Is it
sir.
that easy? No. If a segment is still impure, can you take the decision? If a segment is impure, we will not be able to make a decision, isn't it? Because if a customer is male, unmarried, historically 50% of them have purchased, 50% of them did not purchase. So we are not sure. So it's impossible that we take a right decision everywhere, but at least out of 14 customers, 6 plus 3 plus 3, 12 customers, these 3 segments, we are very sure. And if a customer falls here, still we are not sure, we may get into wrong results, which means we will not have 100% accuracy everywhere. And you're all aware of that, isn't it? Machine learning models, 100% achieving 100% accuracy may not be possible everywhere. So here, these 3 segments, we will be very sure whatever happens because they're all pure subsets. There, if a customer falls, we can very easily say what is his predicted value. If a customer falls in this one, we are still not sure. We will give some prediction, but that may work, that may not work. That is what decision tree tells you. Do not look at the whole data as one group which is impure. Divide the data into subgroups which are pure in nature. Once you divide the data into subgroups which are pure, take the new customer, take the new data point, see which subgroup it falls in, and look at the dominating class. That will be your predicted value. That's what decision tree tells you. Divide the data into subgroups which are pure in nature. That's the whole philosophy of the decision tree. However, when we look at this philosophy, there are some questions that should arise in our mind. The first question that should come to our mind is, there are two columns, marital status and gender. Why did you use gender here? Why did you use marital status here? Can I use marital status first, then gender next? When you have two columns like X1, X2, which column to use for splitting? Isn't that the first question that should come to our mind? Or shall we do it randomly? That's the first question. Yes or no? Which column to use for splitting? Have you thought of it? Or is it random? Or is there any science behind it? That is question number one. What is question number two? Right now you have a small data set with just two columns. What if I have X1, X2, X3, X4, and so on, Xk columns? Is it true that there are so many columns in the real world? Or there are only fewer columns? In the real world data set, there will be so many columns, isn't it? Most of the projects that you are working on right now, minimum 20 columns are there. Most of you, isn't it? Usually you will have somewhere between 20 to 50 or 60. Those many columns we generally consider. So when you have so many columns, which column you will use first for splitting here? Then which column you will use here? Then which column? Then when will you stop? So when you have so many columns, which column again out of these to use for splitting? How do you ensure that you are getting purer subsets, or is it random? These are the questions that we will get. These will be answered by our decision tree theory, which we are going to discuss now. Overall philosophy, I just told you what happens at the surface level, but the nuances and nitty-gritties we are going to see in some time. I'm going to answer these questions with the decision tree theory. Decision tree very smartly, it will tell us which column to use. Very scientifically, it has been derived which column to use when, how do you use for splitting, how do you make sure that you take this whole input and divide it into small subsets that are having only one column that is dominant, one particular topic or one particular class that is dominating. How do you do that? How do you make these pure subsets? Decision tree will tell you there is a particular standard theory that we're going to discuss. Okay, got it? That is the whole philosophy of the decision tree, just at the surface level. Let us get into the details of the decision tree. How do you actually build that tree? But before getting there, let me take a couple of questions now. Please go ahead with the questions. Anybody?
Sir, after segmenting out, sir, male, like here, for example, you're segmented married, unmarried, like that. So if what if all the things are impure subsets, sir? Whatever you are segmented.
So what happens in that case is the prediction. Let's say if a customer falls here, what will be your predicted value? If a customer falls here, what will be your predicted value?
We can't predict.
Like that model cannot say like that, isn't it? It'll give some prediction. Yes or no? It'll give either 0 or 1. We have to say something, right? If a customer is here, male, married, or we will say customer is male, unmarried, we have to give some prediction, isn't it? That prediction will be inaccurate. You cannot predict accurately, but you will give some prediction, isn't it?
Okay.
So the model, if all the segments are impure, the model that you are building, that decision tree model will be very much inaccurate. What do you mean by that? The prediction that you are giving, let's say that if you calculate the accuracy of that model, that will be somewhere around 50%. What do you mean by accuracy is 50% or 55%? What does that mean? That means it's almost like randomly you are guessing whether he will buy or not buy. Yes or no? That will happen when you have the variables that do not have the predictive power. That will happen when the data itself doesn't have the patterns. Okay. If the data doesn't have the patterns, what can decision tree do? No matter what model you are building, the model is as good as input data. Yes or no? The model is learning the patterns from where? Data. Yes or no? If the data itself doesn't have the patterns, even decision tree cannot do anything. So a simple answer to your question is, if still after splitting, if you have impure segments, the model will have very poor accuracy. You cannot use it for predictions. Okay.
Okay.
Sir, in real life scenario, if the data comes as impure, then what do we do?
So what we can do is, let's say in the real life scenario, the data itself that you got, let's say you built a logistic regression model, or you built a decision tree model. The best accuracy, bestest of the best accuracy that you got is 60% only. Okay. No matter what you do, I'm assuming that you have done your best to increase accuracy. You made sure that you did all the data cleaning very well. You made sure that in logistic regression, variable selection, everything you did your best, but you still got only 60% accuracy. That means there is some problem with the data. You go back, talk to your business partner, get more data. When I say get more data, now you can get some more rows. Right now, these are all the columns that do not have the predictive power. You can get some more rows, or you can also get some more columns. Specifically, what am I saying? When I say get more data, am I talking get more columns or get more rows?
Columns.
Get more, think about it. Get more columns. You have to get more columns, because if this variable is not impactful, by adding more and more rows, do you think that will be ever impactful?
No.
You have to bring some more columns that will have some impact. Now, who will tell us which are the impactful columns? Is it the machine learning model, or is it the domain knowledge that will tell us when you are collecting the data at that time, which column to collect? Which column may have impact on the target? Who will tell us?
Domain knowledge.
It's the domain knowledge. You have to study very carefully what kind of features may impact my target. If you're saying a customer will buy or not buy, are you very sure that it will depend only on marital status and gender? Or do you think customer buying or not buying doesn't only depend on these two factors? It depends on age, it depends on spending patterns, it depends on income. If you think there are several other variables that have the impact, then make sure that your data has all those columns. Okay.
Like, sir, if we got the right data, then we can build a pure bucket we can get it.
So basically, if you feel that you have all the columns that are impacting the target, you have covered everything, then the model will definitely find all the patterns, because the model that you built here is learning every pattern from the data only. So finally, everybody will say model is as good as the data. If you are sending junk data, no matter what great, maybe you can build world's greatest model. If you send junk data to it, will you get good results?
No, sir.
No way, isn't it? Junk in, junk out. Model is as good as the data.
So do we have to make multiple regression trees, like identify to get the pure bucket? Like, how do you know that male married, like will
Yeah,
be the
so those are the two questions I'm going to answer in some
Oh,
time.
sorry.
Okay. So right now, I just told you the philosophy of it, but exactly how do you do that? Which variable will you use for splitting? How do you make sure that purity is coming? That's the one that we will get very much in detail. Okay. The rest of the 2 hours will be on that only. Any other questions before we proceed? Ready? Is it clear? Absolutely clear until now? Just the philosophy of the decision tree I told you. In simple words, in 2 sentences, if I have to tell you the philosophy, what is the philosophy? Don't look at the data as a whole, as one group. What you should do? Divide the data into subsets. But make sure that each subset is pure. That's it. That's the philosophy of the decision tree. But how do you make sure that which variable you will select, etc., etc.? Now I'm going to answer. Now let me give you this idea now. Let us suppose you have 100 customers, 100 records are there. 50 customers are buying the product, 50 customers are not buying the product. 100 customers are there, 50 customers are buying, 50 customers are not buying the product. Now, you want to divide this data. You have 2 options. You can divide the data based on income, because you have the income details with you. You can divide the data based on gender. You also have the gender details with you. Now, the question that we ask is, which variable to use for splitting? Is it income variable? Is it gender variable? Let us see what happens if we divide this data based on income. So if you divide this data based on income, 100 customers are there, 50 are buying, 50 are not buying. Divide this data based on income. Out of 100 customers, 60 customers have low income, 40 customers have high income. Okay. That's what we have seen in the data. Out of 60 customers, if I look at them, how many of them are buying? 31 are buying, 29 are not buying. So right now, if you look at the whole data, 50 are buying, 50 are not buying. Is it pure or impure? Whole data.
Impure.
As it is, if I say
Impure.
it is impure, why it is impure? Both the classes are there. Are you getting a feel of this impurity? If you have class 0, class 1, both of them, then that is impure. Okay. Now, when I divide based on income, low income segment, again, this is
Impure.
Impure only. High income, there are 40 customers, 19 are buying, 21 are not buying. Again, this is impure. Now, this is what is happening when you divide the data based on income. This is the result. Alternatively, you can also divide based on gender if you like to. The same 100 customers, 50 are buying, 50 are not buying. Within male, 60 male customers are there. If you divide based on gender, 60 male customers, how many of them are buying in 60 male customers? 48 are buying, 12 are not buying. That means 80% buying, 20% not buying. Within female customers, 40 customers are there, female customers. 2 are buying, 38 are not buying. 5% are buying, 95% are not buying. Now you can divide the data based on income if you like to, or you can divide the data based on gender. If I give you a chance, use any one of these two. Would you like to split based on income? Would you like to split based on gender? What will be your option? What is useful?
Gender.
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 Dividing based on gender is giving us a better, what kind of segments? Dividing based on
Pure
gender is
segments.
giving
Pure.
pure segment. Isn't that our objective? We want to divide the data into pure subsets. When you divide the data into pure subsets, then if a customer is male customer, you can confidently say there is a high chance that he will be a buyer. If a customer is female, you will be very confidently saying that customer will be a
Non-buyer.
non-buyer. But if I tell you a customer has low income, can you tell anything confidently?
No.
If a customer has high income, can we tell anything confidently? 50-50. So dividing based on gender is giving better, purer subsets. Dividing based on gender is giving us better information gain. We are gaining higher information here. We are gaining higher clarity here. But dividing based on income is not giving us a good idea. This is what you have visually picked. You have used your logic to tell that gender is a better variable for splitting. But we are going to quantify this. We are going to use a measure called information gain. That itself is the name of the measure. Information gain is what we are going to calculate for income. That will be a lesser value. Information gain is what we are going to calculate for gender, and that will be a higher value. Information gain for income will be less. Information gain for gender will be a higher value, and we calculate it. So let us see the splitting criterion. What is the splitting criterion? You have to have that particular variable which is giving you purer subsets. First of all, I have to define what is purity. I have to quantify what is purity, what is impurity. So the first measure that we are going to discuss today, the first theoretical measure is measure of impurity, measure of diversity, measure of randomness. Entropy is a measure of impurity. Entropy is calculated for a set S. Entropy is, let's say, if P1 is probability of class 1, P2 is probability of class 2, then entropy is minus P1 log of P1 minus P2 log of P2.
Sir, isn't this like thermodynamics?
Exactly. This is coming from somewhere, thermodynamics, chemistry, isn't it? When do you say this metal is pure? Let's say, when do you say this is pure gold? Tell me. When do you say this is pure gold?
24 karat. Wait.
Let's say I'm giving you gold of 100 grams. When do you say this is pure? What do you mean by purity? That means there is absolutely no other metal which is mixed. Yes or no? Are you with me? Let's say you have gold, you have bronze. Let's say you have 99% gold, 1% bronze. Then will you say it is pure? Let's say you have 60 gram gold, 40 gram bronze. Will you say it is pure?
No.
Entropy is a measure of purity. It will tell you, or it's a measure of impurity, which is opposite of it. It will tell you how impure a particular set is. But here we are not looking into metals or anything. We are not looking into chemical substances. For us, those two classes, what are our two classes? Class 0 and class 1. For example, you have 100 customers. In which scenario you will say, yeah, this subset is, or this set is very much impure, totally diverse, totally random. What value of P1, what value of P2 will lead to a totally impure, totally random, very high entropy? Tell me.
50-50.
If P1 is 50%, probability of class 1, probability of class 2 is 50%. If there are 50 buyers, 50 non-buyers, can I say that is totally impure? That's the worst thing that can happen. Think about it, all of you. Would you agree with that?
Yes, sir.
Yes, sir.
Isn't it?
Yes.
In fact, entropy is highest if you put P1 as 0.5 here, P2 as 0.5 here, and calculate entropy, you will get the highest value of entropy, because entropy is a measure of impurity. Impurity is highest when you have P1 0.5, P2 is 0.5. Highest impurity, highest diversity, highest entropy. What about the opposite of it? You have 100 customers. What value of P1, what value of P2 will lead to pure? This is totally pure. There is no impurity in it. When do you say this set is totally pure? Absolutely no impurity. In which scenario? What value of P1, what value of P2 will lead to that?
There might be two scenarios, either P1 0 or P2 0.
Let's say P1 is 100%, P2 is 0. That means 100% buyers. That's a pure subset. What about the other scenario? There can be another scenario of purity as well. What is it? P1 is
P1 is 0.
0. P2 is 1.
P2 is 1. That is also possible. That is also pure non-buyer set. 100 out of 100 are buying, that's one scenario. 100 out of 100 are not buying, that is also another scenario. In both the cases, if you put P1 0, P2, P1 is 1, P2 is 0, or the other way around, entropy, you will get the least value. In which scenario? When P1 is 1, P2 is 0, either that way or 0, 1. In that case, you'll get the least value of entropy. Entropy is a measure of impurity. That will help us whether there is a pure set or whether there is an impure set that we are handling. Tell me once again, at the end of the decision tree, at the end of the segmentation, what kind of subsets are you looking for? High entropy subsets, are they useful, beneficial for you? Or low entropy subsets, are they useful or beneficial for you? What kind of subsets are beneficial? What are we looking for? High or low entropy?
Low entropy.
Low entropy. Low impurity. That means high purity. We want pure subsets, isn't it? So let us get a better understanding of entropy. We will do some calculations manually. Usually you don't need to do it, but we will do it to get an idea, a better idea on the entropy, better feel of entropy, so that we don't forget it. Let's say if you have a subset where P1 is 0.5, P2 is 0.5, what will be the expected entropy if you calculate it? If you put that in the formula, how much will you get as entropy?
Probably be less.
P1 is 50, P2 is 50. Will it be lesser or higher? Entropy is a measure of
Higher entropy.
purity. It will be higher. Highest entropy you will get. Think about it once again.
Sir.
Yes or no? Entropy will be less or high? It will be highest. Maximum entropy. If P1 is 0, P2 is 1. In that case, entropy will be
Zero.
Yes, almost 0.
least, almost 0. Now think about this scenario. P1 is 45%. P2 is 55%. In this case, entropy will be near to 0 or near to 1.
Near to 1.
That will be near to 1 because almost impure. What about this scenario? P1 is 0.05, P2 is 0.95, 5 versus 95%. In that case, entropy will be
Near to 0.
near to 0. Got it? These are the expected values, but let us do a calculation and see exactly what are the entropy values. That will be our first exercise for today. I want you to go to that decision tree code file, and this will be our first exercise to calculate entropy manually using that formula. So do you have the code file open, anybody? Let's open the code file in the classroom. I have posted the material, right? So we have the class file posted in the chat window. You can open that. So what I want you to do is, I want you to calculate when entropy P1 is 50%, P2 is 50%, what's the entropy? What's the entropy for 0, 100 for those cases, and give me the exact values. 50-50 case, what is the entropy? How much is the entropy for 50-50 case when you calculate it?
1.
It is 1. Since log 0 is not defined, we will take almost 0. Almost 1. If you take this way, what will be the entropy? Almost 0, almost 1. In that case, entropy will be
0.00.
almost 0, isn't it? Nearly 0. What about 45-55 case? What is the entropy that you are getting?
0.99.
0.99. What about this one? 0.28.
0.28.
All of you, have you opened the code file? Anybody lagging? Anybody struggling with the code file? Struggling with the syntax? Please let me know. Is it syntax easy to follow? There's nothing difficult in that. Yes or no? Just in the formula, this math dot log dot and all that. If you look at it carefully, you'll be able to follow this, isn't it? Tell me once again, if entropy is high, what does that mean? Is it a pure subset or impure subset?
Impure subset.
Impure, isn't it? Entropy is a measure of what?
Impurity.
Randomness.
Randomness or impurity. Diversity, isn't it? Chaos in the system. So tell me once again, if this is segment 1, this is segment 2, segment 3, segment 4, what kind of segments are you looking for? What are beneficial for you? What kind of segments are beneficial for you out of S1, S2, S3, S4? Which one is most beneficial? The first one is S2. After S2, which is the next best one that you would pick?
S4.
S4, isn't it? right? So once again, entropy is a measure of impurity. For example, if you have P1 near to 0, P2 near to 1, in that case, entropy will be less, impurity is less. The same way, if P1 is near to 1, P2 is near to 0, in that case also entropy will be less. But in the cases when you have 50-50, P1 50, P2 50, 40-60, 60-40, in those cases, entropy will be high. Once again, what kind of segments are beneficial for us? S1, S2, S12, S13, those, or S6, S7, S8, those. What kind of segments are beneficial for us?
Sir, S1,
S1,
S2,
S2,
Isn't it? Those are the segments that are very much beneficial for us because we can take the decision easily in those subsets or the segments. Okay. All right. Now comes the actual final formula, which is information gain. So what is information gain? Information gain is calculated for a variable. For example, if you have this set, if you want to divide this set, let's say if you want to divide this set based on x3 variable, information gain is entropy before splitting. Entropy here, entropy before splitting, minus entropy or average entropy after splitting. Tell me one thing, maybe entropy before splitting may be high here. That means there is a lot of randomness, there is a lot of impurity here. If this variable is good, if it is really beneficial, what should be the entropy after splitting? Here, what should, if it is a very good variable, if that variable has the power, what should be the entropy here? What should be the entropy here after splitting?
0 or 1.
0, 1,
It should be near to what?
near
Zero.
to
0.
Near to 0. That means entropy has to be low here. Entropy has to be low here if it is a good variable, isn't it? So information gain is entropy before split. How much was the entropy before splitting? Maybe it's a higher value minus average entropy after split. So how information gain is calculated? Let us see. The same example, earlier we have split based on income and gender. Earlier anyway you have picked gender is the variable that I will use. But now you have to quantify it. How good is the gender variable compared to income variable? Let us see how information gain is calculated based on entropy. So the final formula is information gain. That's what we use everywhere. Okay. So here is how information gain is calculated. Entropy before split. So P1 is 0.5 here. P2 is 0.5 here. You have already calculated for this case. What is entropy? What's
1.
entropy for
1.
this case? 100%, isn't it? How about this one? After splitting, P1 is 0.5 to 52%. P2 is 0.48. Entropy, can you make a
Near
guess
to 1.
how
Near
that
to
would be?
1.
Very
Near
small
to
value or very near to
High
1?
value.
High
High
value.
value.
To 1.
When you actually substitute and make the calculation, you will get 0.99. 99% is the entropy. How about this one? P1 is 0.48. P2 is 0.52. How about this one?
Near to 1.
So that will also be near to 1.
Higher.
Higher. Now look at the information gain for income variable. Information gain for income variable is entropy before split, which is like 100%, minus weighted entropy after split. There are 60 records here out of 100. There are only 40 out of 100. Can we give equal importance to both of them? We cannot. Sometimes there are 90 records here, there are 10 records here. Can I give equal importance to both of them? No, I have to give weightage. So 0.6 into its entropy, 0.4 into its entropy. Information gain when you split based on income variable is 1%. Information gain is 1%, which means before splitting, 100% was the impurity. After splitting, on an average, how much is the impurity? You got it down from 100% to, on an average, you got it down to
99%.
99%. How much have you gained? What is your lift? What is your information
1%.
gain? How much?
1%.
Let's come here. What will happen if you do the same thing on gender? Once again, tell me, what will be the entropy here? 50-50 case?
100%.
100%. So if you come here, 80-20, I'm not saying this is perfect pure. There is still impurity. When you do the entropy calculation, you will get somewhere around 72%. Again, this is not 100% perfect, but somewhat better, much better. When you do the entropy calculation, you will get something like 29%. So entropy before split minus weighted entropy, 60% into its entropy, 40% into its entropy. Information gain for gender variable. Yes, it is not giving 100% pure subsets, but much better. Information gain for gender variable is entropy before split minus weighted entropy after split. That is 45% somewhere. Previously, before splitting, 100% was the impurity. On an average, you got it down to 55%. From 100, you got it down to 55%. What is the lift? What is the information gain that you
45%.
got? How much is the information gain? From 100, you got it down to 55, which means 45% is the information gain. Now tell me, if you have two variables, x1 and x2, which variable would you use for splitting?
X2
Highest
sir.
information gain.
You will calculate the information gain of x1. You will also calculate the information gain of x2. You will use that variable which has, which means in terms of information gain,
Higher information gain.
you will go for that variable that has higher information gain. That was our question number 1. Do you remember that? If I have 2 variables, which variable will be used? The answer to that is calculate information gain, use a variable that has higher information gain value. Okay. What about the second question? What if I have x1, x2, x3, and so on? Xk variables are there. K can be 20, 30, 40. Several variables are there. Which variable I will use for splitting? Out of all these variables, which variable I'll use for splitting?
The one with higher information.
I will
gain.
calculate the information gain of x1, x2, x3. First of all, I have to calculate the information gain of every variable. Yes or no? Calculate the information gain of every variable. Use that variable that has the maximum information gain. Information gain is the critical concept that will tell us which variable to pick to make sure that you will get better, purer subsets given the set of all the variables. Have you got the concept of information gain?
Yes sir.
Yes, sir.
Basically, earlier you have manually picked gender. We are trying to quantify it. We are trying to give a number so that we can automate this process. No matter how many variables are there, we can just calculate this number and compare them, find out the best one out of them. With that idea on the information gain, we are now ready to discuss the decision tree algorithm. Here is the decision tree algorithm. What is the decision tree algorithm? What is the main objective of it? Decision tree will take the whole data as input. This is the input, whole data. Divide the data. What is the output? It will divide the data into what is expected out of decision tree. Tell me.
Subsets.
Divide the data into subsets. But what is the condition about these subsets? Are they random subsets?
Pure subsets.
Divide the data into, specifically, we have to very specifically say divide the data into pure subsets. When you look at these subsets, you will find them pure. For a layman, how do you explain purity? What is purity? Tell me. What is purity or what is impurity? What do you mean by that?
There is no randomness.
What is वो भी confusing है ना? So there is no
Sir,
randomness.
the one
Means
with
like
high entropy will be impure.
So basically, you try to, like, since you have understood the concept, now I understand that you understood the concept, like try to make it easy for the person who is listening to you. Okay. Make sure that you're using lesser jargons or something. Try to use simple words and tell them that if you have 2 classes, class 0, class 1, only one class variable is dominating, or take an example and try to explain that. Like basically nowadays in the interviews, they're asking questions like explain it to a layman, explain it in simple terms. Those are the questions that are coming in. Okay. All right. Now see how decision tree divides this data into purer subsets. Let us see. Okay. First, let us take a data set. Let's say there are 10,000 records in the data set. You have x1, x2, and so on. Xk columns are there. You have the full data with you. Decision tree first tells us divide this data into 2 subsets. Decision tree does that. Exactly 2 subsets, not more than that. Always a binary split. Now, which variable will be used for splitting? Is it x1 or x2 or xk? Randomly any variable, or the last variable, or the first variable? Can you tell me which variable will be used for splitting here?
The one
Highest
with higher
information gain.
So to decide that variable, we need to calculate the information gain of all the variables. Yes or no? And then
Yes sir.
use that variable which has the highest information gain. For example, that is x17. Just for an example. Okay. x17 has the highest information gain. I'm splitting it. Let's say there are overall 20 variables. x17 has the highest information gain. So that is giving us somewhere around 6,500 records here, or let's say 3,500 records here, 6,500 records here. Now, do you think that these 3,500 records are absolute buyers? These 6,500 records are absolute non-buyers. This is absolutely pure. This is absolutely pure. Is that going to happen in one shot?
No sir. No sir.
Or again, there is still zeros and ones here. Again, there are still zeros and ones here. Again, there is impurity. Again, there is impurity. Yes, this is better than this, but still impurity is there. What is going to happen in real life? What do you think?
As always, impurity.
There will be impurity. Yes or no? Within one shot, we will not be able to divide into purer subset. That means whatever problem statement we have here, impurity is there, you have to divide into purer subset. The same problem statement is here.
Right, sir.
Again, the same problem statement is here. But earlier there were 10,000 records, but here there are 3,500.
6,500.
Here there are 6,500, but again, the same problem is arising here. What do you need to do? Again, you divide that into purer subsets. But this, imagine this is just a subset of the 10,000 records. You have again a data set. You have all the column records, etc. Everything is there, but it's a smaller data. Again, you divide that into 2 subsets. Now, which variable would you use here? Which variable
Then we
will
will
you use here?
calculate information gain.
Again, you calculate the information gain of x1, x2, and so on, x20. Use that variable which has the
Higher information.
highest information gain on this subset. Isn't it sounding like recursion? Whatever you did here, you're just simply repeating that at every node here, isn't it?
Yes, sir.
To get the best pure subsets. For example, there are 2000 records here. There are 1500 records here falling. Let's say once you calculate information gain of every variable here, imagine x3 is the variable that has the highest information gain on this subset. You come here. Can I directly use x3 for splitting here? Is that going to work?
No, sir.
A variable which has higher information gain on this subset, is there any guarantee that it will have the same information gain on this subset, which will be highest?
No.
Which variable I'll use here then?
Whichever is highest for this.
Again, recalculate the information gain of all the variables on this subset. Use that variable which has the highest information gain on this subset. Make sense? Use that variable which has the highest information gain on this subset. For example, once you calculate the highest information gain, you got that variable to be x2. Maybe there are 4500 records here, there are 2000 records here. If I keep on splitting like this, when do I stop? I'm keeping on splitting like this. What is the stopping criteria? What is my
When all the
ultimate
subsets are
goal?
pure.
When there is purity. Let us suppose 1500 records are there. Almost all of them are buyers. All of them are buyers. What shall I do? Shall I further split it, or this is sufficient here?
Sufficient, sir.
What is our final goal? Our goal is to get the purer subsets. I got the pure subset. I'll stop this. Does that mean I'll stop the whole algorithm, or shall I continue with the rest of them?
We continue, sir.
If there is a chance, I'll continue. 2000 records are there. If all of them are class 0 or class 1, all of them are non-buyers, then I'll stop it. The remaining ones will continue. So that is one of the stopping criteria. What is the first stopping criteria? Purity is achieved. Whichever node has purity achieved, that node will be stopped. The remaining nodes will grow. What is the other stopping criteria? Sometimes it is still impure, but this is the best that you could get. There is no variable that can make it further pure. That means, let's say 90% is one group, 10% is other group, but there is no way you can make it like 100, 0. There is no other variable that can make it better. Is it possible that everywhere you will get absolutely pure subset? Is there any rule?
No.
It depends on the data. So you have achieved the maximum purity. There is no variable that can make it further pure. Then also it will stop. This is the best that you could achieve. There is no variable that can make it further pure. Then also it will stop. This is the best that we could achieve. There is no variable that can make it further pure. There is no variable that can make it further pure in those. In fact, that is the most frequently applied stopping criteria, because it is impossible to achieve absolute purity like this. There will be some segments that will be absolutely pure, but there will be a lot of segments that are somewhat impure, but that is the best that we could achieve. That way, decision tree takes the full data as input. It divides the data into segment 1, segment 2, segment 3, segment 4, segment 5, segment 6, like that. It will divide into subsets or the segments. What is the rule of these subsets? When you look at these subsets, are they random subsets? What is the speciality of these subsets or the segments? When you look at each of these segments or the subsets compared to the previous level, compared to the initial starting point, what are all these? These sets are very much
Pure.
Pure. What is the advantage of purity? When a customer falls in a pure subset,
Decision.
you can take the decision easily. Once again, let's recap. What's the decision tree algorithm? This is how it sounds theoretically. But now that we understand how it works, decision tree algorithm is select a leaf node. In the decision tree terminology, the first node is known as a root node. Then you have two nodes below this. This is also known as parent node. And the ones below are known as, if this is parent, these two will be child node. And this way. If there is nothing below this, if this is the last node in this tree, if this is the last node, then this will be called as
Leaf.
leaf node. So all the terminal nodes are known as leaf nodes. So what decision tree tells us is select the leaf node. In the beginning, if you have only one node, which is the root node, that will be the leaf node, isn't it? In the beginning. Find the best splitting attribute by calculating
Information gain.
Information.
Split the node using the attribute which has maximum information gain. Split it. Then you will be left with two child nodes. Go to each child node. Repeat step 2 and 3. Are we repeating the same thing again and again?
Yes.
Split it. Split it. Again, split it. Again, split it. What's the stopping criteria? There are a couple of stopping criteria. What is the first stopping criteria? Stop this when there is purity achieved. Stop this when there is purity achieved. Otherwise, keep on growing. Okay. What is the other stopping criteria? If there is no other variable that can make it further pure, if there is no other variable that can make it further pure, then also stop it. If purity is achieved, well and good, stop it. If there is no other variable that can make it further pure, then also you stop it. That is how decision tree takes the full data as input. It will give you all these subsets as output. That's the decision tree algorithm. Do you think, are we going to write the Python code for this algorithm, or simply we supply the dataset name, supply the X and Y variables, and some package will give us this decision tree automatically? As a data scientist, are we going to write the Python code, or will there be a ready-made function available for us to take care of this?
So ready-made function.
There will be always ready-made functions. As a data scientist, most of your time goes into coding or interpretation of the results. Tell me. Where do you think?
Interpretation of results.
Interpretation of the results. That is important, isn't it? So obviously all this, in fact, this whole theory also, we will not get to see anything. Everything happens in the background. All, like most of the data scientists, what do they do? Even though they do not know the concept of decision tree, simply you take the data, supply the variables, then you will get the decision tree result directly. But how exactly first node was taken, which variable was used here, why the tree stopped here, all these things, the logic behind that is what we have discussed here. This is all the theory. Once we apply this theory on a case study, then only we will get some more clarity. Now we are going to get into a case study. But before getting into the case study, let us take some questions here.
I have a question.
Yeah, please go ahead.
So while stating, when we are taking one variable,
Right.
is it possible that the same variable is being used in some other nodes also, or it is been once it is used, it has been erased? Is it that?
So there are two types of variables. One is categorical type. Okay. The other one is continuous. Let's take example of a variable called gender. Now, if I split based on gender, male here, female here. Now, all these guys who are coming here, everybody is male. There's no way I can further use gender, isn't it? In this case. Yes or no? Because like within male, you cannot categorize based on gender.
Correct.
So in that case, even if I try to use this variable, automatically information gain of this variable will be 0. Decision tree will never pick it up. Even if I calculate, even if I try to use it, information gain will be 0. It will never be picked up. There's another type of variable, continuous. Give me an example of continuous variable. Income. First, I have used income. Income less than $6,000. Income more than $6,000. Is there a chance that I can somewhere use further later on here? Can I use further income? Split it based on income. Is there a possibility?
Yes, sir.
How can I use further income? At some segment, at some level, if I split based on income at, let's say, 3,000, less than 3,000, more than 3,000, then I'm achieving purity. Is there a possibility for that theoretically? Think of it. Maybe. Possibility is there. So if a variable is continuous, then there is a chance that it may occur again. If a variable is categorical, automatically it will not occur. Okay.
Okay.
Once again, this is just a theory that we have discussed. A lot of people ask me, sir, is statistics necessary to understand machine learning? Do we need a lot of mathematical background? Yes, I say maths and stats are required, but they're not that hard to follow, isn't it? When you're guiding somebody, tell them that go confidently. A lot of people ask me, sir, I have a little less knowledge in coding, less knowledge in Python. I don't think I can follow machine learning. Is that really true? Try to guide the next set of batches. Tell them it's not that hard if you understand. It's all about logic. Let's get into a case study then. Any quick questions before getting into the case study?
So that formula, like, I didn't get it. That minus P1 and all.
Right.
Like,
Yeah.
Entropy.
Yeah.
No, I didn't like. You have written some minus P1. Sorry, minus P. And all. I didn't get clarity in that.
So just take that as a formula. Okay. So basically, that will quantify what is the entropy, what is the randomness in the system. Okay.
No, that I got, sir. Like there is a P plus P minus is there, and also like minus and also what is
So an
exactly
easy way to look at that is, let's say 0.5. So the formula is minus P1 log to the base 2 of P1 minus P2 log to the base 2 of P2. Okay. So let's get into this logarithms theory. Let's say 100 customers are there. 50 are buying, 50 are not buying. Okay. What is P1 value? Probability of buying is how much?
0.5.
0.5, 1 by 2. Probability of not buying, P2 value is
1/2.
1 by 2. Let's calculate entropy here. Minus 1 by 2 log to the base 2 of P1, 1 by 2, minus again P2 is 1 by 2, the log to the base 2 of 1 by 2. What you can do in logarithms, if you have log to the base 2 of 1 by 2, you can write 1 by 2 as 2 power minus 1. You know that? We can write like this. Yeah, agree? Minus 1 by 2 log to the base 2 of 2 power minus 1. Now in logarithm, what you can do is minus 1, you can bring it to the front. Are you aware of it?
Yes, sir.
Do you agree? You can bring
Yes,
that
yes.
to the front. हाँ, कर
Yes,
सकते हैं ना?
right, right.
Especially those who are recent with studies. अब तो agree करोगे, right? You can
Yes.
bring it to the front. So you bring that to the front. That will be then this minus is kind of countering that one. Yes or no?
Yeah, yes.
Yeah. Now that is what 1 by 2 log 2 base 2. What will be log 2 base 2?
0.3.
Log 2 base 2 by log 2 base 2 is 1. Okay. Log a base a is known as 1. Okay. Then again 1 by 2. Here there is a minus. Again that got cancelled with minus. Again plus. Here this minus and this one I'm saying. Log 2 base 2 will be 1. So 1 by 2 plus 1 by 2, 1. That's the whole derivation of it. Okay. The reason why I did not go into this is a little bit of these formulas are required.
No.
That's why. Yeah.
I got it, sir. Actually, there is P plus P minus, but that's why I'm confused.
Like basically, basically it's just the notation. So instead of P1, P2, I'm calling the probability of class 0 as P plus and then P minus. Okay.
Yeah. Okay. Thank you, sir.
Now it makes sense how 1 is coming and all. Yeah.
Sir, one more question, sir.
Yeah.
Sir, if entropy is less, then information gain will be more. Is this what I have understood? Is this correct?
Information gain formula is entropy before split minus entropy after split. For example, here entropy is less. Like you're talking about which entropy? There are like 3 entropies here in information gain formula. Which entropy are you talking about?
Means I'm talking about the child node.
Child node. One node or both of them?
One node. Consider for one node.
Let's say there are only 100 records here. 95 are falling here. 5 are falling here. For this set, entropy is almost 0. But for this set, entropy is high. Do you think information gain will be high in that scenario? I'm giving you a counter scenario to your statement. It is weighted entropy after split, isn't it? Theoretically, entropy before split minus entropy after split. Is it entropy after split of one particular segment or both of them weighted? Think about it. Are you thinking? So you told entropy is
Only
less.
one, right?
So what I'm saying is entropy is less. Information gain is more. Is that true? That's what you're saying, right? When will be information gain higher? Here, if you have higher impurity. After splitting, if you have lesser impurity, then your information gain will be higher. Okay. So if you have confusion, simply don't think of 2 values. A shortcut in that is just calculate the information gain using the formula and take that variable which has higher information gain or lower information gain.
Higher
Information gain. Simply blindly go with the variable that has higher information gain. Okay. Don't even consider entropy. Automatically information gain will take care of that.